Okay. So the content of today is like this. The first, like yesterday, so we are going to check the software and data set. Then the next step, sorry, I missed typing. The next step is explain about the forest function and sorry, I forgot to update. So the next I'm going to talk about the forest function and we are going to try to analyze forest function. This is the content for today. Sorry, I didn't update it here. Okay, so far, I think everyone okay. So can you open QGIS? And so can you check the processing toolbox again? So when you finish, please click response button. Okay, so did you open and did you check the QGIS? Share されてる。わかんない。Okay, the next, can you check the data for today? Data set. Can you see do you have the forest function folder?画面共有されてません。すみません。いつ切れた All right, do you have the folder? So, can you push the response button if you have?
For forest function?
Yeah, forest function. Thank you, Nishikawa-san. Mm. Mm. ガッサン。これ。んガッサン。
Gas?
ガッサン。
Gas?
ガッサン。Thank you. Gassan?
Yes.
So, do you have the folder?
How many layers do we have to add for QGIS?
Not yet, not yet. So, anyway, do you have the folder?
Yeah, we managed to find the folder.
Oh.
We only add one layer, the FMU layer.
Sorry, I can't hear you well.
Come again?
Hmm? Jeff-san.
Yes.
So can you check the each PC? Everyone has a folder or something trouble? Jeff-san, Jerry-san. So yeah, please support.
Satu layer no. FMU layer no. Yeah, everyone's okay.
Okay, thank you. All right, so before lunchtime, I'm going to explain the concept of the forest function. So forest function. I think some of you know the forest function. It's not so difficult. For example, forest has a main variety of the function like ecosystem services. So yeah, for example, like how to say, keeping the biodiversity or like keeping soil and purify the water and of course produce a timber. So this is a concept of the forest function. So according to the ITTO criteria and indicator for sustainable forest management, so yeah, they mention about the forest function. So can you see the table this in the screen? So you can see the objective 3 maintains the multiple function of the forest to deliver products and environmental services. This part is mainly related to the forest function. So according to this criteria, you can see the 3 function. Yeah, forest production, timber and non-timber production, and forest diversity, and soil and water protection. So here, right. So and then if the when we compare the criteria, 3 criteria to the code of logging practice in Solomon Island, so somehow it corresponds. So for example, criterion 4, forest production. So yeah, there are a variety of rules to when the harvesting operation conducted. So yeah, so this part is correspond to the forest production part. And also forest diversity. So I read the code of logging practice in Solomon Island. So mainly like conserve the mountain or high altitude area is related to this part, and also protected area and a forest reserve, area of ecological or scientific importance, such as wetland and mangrove. So those are related to the forest diversity, I think. So this matrix, I created this matrix. This is according to my understanding. So, and then so criterion 6, soil and water protection. So for this part, in the code of logging practice, so it mentioned about landslip areas and a river and stream with buffer area, and so gully area and a steep slope area. Those are restricted to conduct the harvesting operation. So this part is so strongly related to the criterion 6, I think. Yeah, okay, so yeah, already, so according to the logging code practice, I think somehow already the forest function is considered in the Solomon Island. Okay, so on the other hand, so yesterday, so we use a FMU data set. FMU is a forest management unit. So for example, in Japan, about the forest functions. So each forest management unit has a forest function. Yeah, for example, this map. So for example, green part is like a conservation. And so this purple part is prevent the landslide. Mainly the 5 or 6 maybe the 6 category. There are 6 categories. In this area, only five categories, but so there are 6 categories in the Japanese forest management. So for example, water protection is near flatland. So this is mountainous. Colored part is a national forest, and so this is relatively steeper than the this part. So, okay, and then so when you check the attribute table of forest management unit in Japan, sorry, the many of them are Japanese, but can you see this part, forest function? So each forest management unit has a forest function to be achieved. Okay, so according to this table, so this forest function is, for example, let me see. So forest function becoming like a target for the forest management. Yeah, for example, like the area, the forest FMU for which has a water protection forest function. So, sorry, water protection become a target for this forest management unit. So in the blue area, so forest management is aim to enhance forest water protection. So yeah, again, I need to say that this forest function is like a target of forest management. Okay, so those data set is already open to the public in Japan. So this one is I already downloaded from the website. So Ministry of Land of Japan. Then so everyone can use this FMU and also that some of the attribute. Okay, so this picture is a main part of today. So sorry, maybe some of you may confuse this part. So please check it. So to evaluate the forest function, so there are a variety of the parameters, factors, yeah, such as topography, like elevation, slope, or weather condition, or vegetation condition. So using those factors, we can evaluate the forest functions. Yeah, so for example, please suppose timber production to evaluate the timber production. So according to the, how to say, to achieve the efficient work for timber production. So in this case, how to say, please consider the criteria to know the, how to say, efficient place for the timber production. Yeah, for example, like maybe steeper place is not efficient to work. It's become hard. And if the distance from road is very far from the, the distance, how to say, the area to harvest is really far from the logging road, main road is also like costly. It's taking time. And also, for example, high elevation area or, for example, some, how to say, accessibility is really low. It's become really hard to get timber. So like this criteria, so you can evaluate the forest function. For example, the slope is moderate to flat, and then the weather condition is, how to say, the not dry land. And also, for example, distance from the factory is really close or something like this. So, so we can evaluate using the variety of the factors. So for example, but there are two ways to evaluate the forest function. So the first approach is using almost all factors. So the mainly including vegetation or not. So for example, including vegetation. So if you use all factor including vegetation data, so vegetation means a forest condition, current forest condition. So it become, for example, evaluating the current status of the forest function. So for example, about the soil loss, if the, yeah, in the steeper area, if there is a big plantation area, palm oil plantation, I think soil loss become more severe. But in the steeper area, there is a good natural forest. The soil loss become, I think, decrease. So forest is a key point to evaluate the forest function. So yeah, please remember that mainly including the current vegetation data, it's become an evaluation of the current status. And then on the other hand, if you remove the vegetation data, just only use like a topographic data or weather condition. So in this case, it's become like a potential of the land. So for example, like this picture. So this picture doesn't have a vegetation, so only the topography. So when we use the topographic information to evaluate the forest function, so it's become like a potential of the land. Yeah, for example, steeper place become potentially, how to say, the steeper place become a high potential area of soil loss, for example. So, or landslide. And then so without a vegetation condition, only evaluates like a distance from road or steep slope or elevation or a soil condition. So it's become a potential of timber production. Okay, so this potential of the land become how to say, become a target. So for example, yeah, potential of land become a target of the forest management. For example, if the potential of soil loss potential is very high, yeah, like steeper place, so we should care the forest management. Then so we should enhance like a forest function of sediment retention in those areas. So so far, make sense? Sorry, this part is a little bit complicated. So anyway, I want you to know that to evaluate the forest function, there are two ways, like evaluating the potential of the land or evaluating the current status. The key point is using current vegetation data or or not. Okay. Yeah, I hope you got it. You got this idea. So then, for example, today, as an example, we want to focusing on the soil loss. If we evaluate the potential of soil loss, then so if the soil potential is high, we should care the forest management. Yeah. Then so something like this. Okay, so we are going to use the very famous model named USLE. So this one evaluates the soil loss mainly based on the topographic data and soil data and weather condition, rainfall. So like this. So this is a picture of the Guadalcanal Island. So for example, using the rainfall and the slope and the soil condition, then so we will evaluate the soil loss, potential soil loss. So in this picture, like a reddish part is a high potential soil loss area. Then so bluish part is low. So I think here is Honiara かな? I think near Honiara. So first we are going to create this map, evaluation map based on the USLE. And then so the next, we are going to summarize the soil loss by FMU. So this part is same as yesterday. So we tried the summarizing function yesterday. So yesterday we summarized the data of forest loss, but today we are going to summarize potential soil loss. Then so we are going to make 5 ranks, and then so we can think how to use this map for the forest management. This is a total today's procedure. Yes. Okay, so far, do you have any question? Okay. All right. So can I go next? Okay. So this slide is a little bit complicated. So sorry. This is explanation of the model, evaluation model of soil loss. Very famous one. This model is used so very common in the world, USLE. So this is the equation. The USLE equal R multiply K multiply LS something something. So I think it looks very difficult, but so the meaning is not so difficult. So for example, the R is rainfall, K is soil condition, and then LS is slope, and C and P is additional factor. So, but mainly, this USLE is evaluated by 3 factors: rainfall, soil condition, and slope. Right? Then, so yeah, like this. If the rainfall is very high, the soil loss will be accelerate. Okay? So, and then soil condition. This is a source of, this is a main source. So if the condition is easy to flow, the soil loss will be how to say high, and it's become high potential area. So for example, yeah, like a soil condition, sand and silt is like a high possibility, and then clay is low. And then so slope condition. Yeah, slope condition. So if the slope is steep, the risk become high. And if it's flat, yeah, risk become low. And then, so if the slope is very long, so wide, in this case, risk become high. The lots of land can be slided. And then if it's short, not so much. So, and then C and P is like a management, considering the management or conservation practice. So if you the area has some like activity, like a farming, it's based on the vegetation type. So the how to say vegetation somehow prevents soil loss. So then we can consider the vegetation type as a C factor. And then support practice like a conservation factor, like how to say make a dike or how to say bank or something. Yeah, not so important. Anyway, that we are going to think about rainfall and soil condition and length of slope. So then this is a combination. Rainfall is high and the soil loss is, soil condition is how to solid, and then slope is flat and short. Or for example, rainfall is low, but the steep slope and the soil condition is sand or silt. So combine those concepts, we can evaluate the land. How to combine those factors? This is just a multiply the value of R and K and LS. Yeah, so anyway, no need to remember everything. So for example, USLE formula. But so please remember to evaluate the soil loss, we need to think about the factor is rainfall, weather condition, and soil condition or topographic condition. So we can mix those factors to evaluate the soil loss. So okay, so now I think 12 o'clock, right? Yeah. So yeah, I think some of you are hungry, right? Okay, so after the lunchtime, we are going to calculate the USLE, the R factor and K factor and slope factor. So it's going to be a little bit complicated, but so no worries. For this time, I want you to understand the concept of the, for example, forest function. So this one, we are going to evaluate the potential of the land. And then, so evaluation is based on the model. So this time, just example, we are going to use USLE to evaluate the forest loss. The model is sometimes, how to say, sometimes you think difficult, but so in real, when you understand the concept of the model, yeah, like acceleration and brake for soil loss, it's a combination. So it's become, I think, I hope easier. Stanley-san. Yeah, okay. So far, do you have any question? Thank you. So, can you come back after lunch? So, I'm worried about after this explanation. So, after lunchtime, how to say, you can't come back.
Okay. So shall we have a lunch? And let's start from the 1 o'clock. 1 o'clock.
1 o'clock.
Yeah.
Okay.
Okay.
Thank
So
you.
let's have a break.
Yeah, thank you.
Oh iya, Bang mau obrol dia mah lagi di bucket ya. Oke. Tadi bilang sebagai diri, ya saya mau datang. Force function.